Hello and welcome to our next lesson, which will be 1.4, lines and their measure. If you want to pause the video, put this on the table of contents. This will be my page 5. You're more than welcome to. So I'm going to my page 5. If you also want to pause and write this title down, you are encouraged to. And let's jump into it. We have a few new definitions that we need to go over. Lines and their measure. So lines, there are a couple variations of what lines are. As we know, lines are 2 points that go on a line is a pair of points or infinitely many points that go on in both directions. So there are infinitely many points on this particular line. If I call this, for instance, A and B, this would be line AB. But we also have something called a line segment, or in short, a segment. Segment is different than a line, and a segment can be measured. It has 2 endpoints. So it is a line that can be measured and has 2 endpoints. And we will draw an example of this. So right below this, I'm going to draw 2 different points. Okay, let's call this A and B, just like we have been. So A and B. It's clearly, there's no arrows on the ends, so this is not not a line. This is officially a segment. Okay, and we could actually define this as having, like, from point A to point B, there is a distance there. So we name this differently. Okay, we call this segment AB. I don't recommend writing segment every single time. Or you could even use just the AB notation. But we need to know the difference between what a line is and what a segment is. A line has arrows on the end, but we definitely don't see them on a segment. So what we do is we actually just put a line above the AB without the arrows. And this is what a segment it looks like notation-wise. So we could say AB, or even we could reverse this. We could call this BA, segment BA. Okay, and oftentimes we'll say the measure of AB. That's another way to say it, because it has some definite measure or length. We could say, okay, from point A to point B is 2 miles. From your house to a friend's house is 6 blocks. There's an actual unit of measurement that we could use. So that is what a segment is, and that's how you differentiate it notation-wise and visually. That's how you differentiate it between a segment and a line. So we have another new term, and that it is a word that we're going to be using a lot throughout the pretty much the entire year, is the word congruent. Congruent means having the same measure. Having the same measure. Now, what this means is it could be segments that have the same measure, angles that have the same measure, or volumes even. But we'll get there. So, having the same measure. So if I say something is congruent, that means they pretty much equal to each other. So this is the symbol for it. I think I've talked about this a little bit on the first day. It literally just means equals. This is our geometry term for equals. Okay, so if I draw 2 segments, let's call this JK. Let's draw another pair of segments. Let's call this M and N. And let's pretend that these segments are in fact congruent. So if I said we have congruent segments, we should know congruent segments. That just means there are 2 or more segments. I'm going to put this or in parentheses, or more segments with the same measure. So if I said, for instance, JK had a distance of 2 blocks, Oop, let's do this in pink. Anything I write down in pink, you do not have to copy down. It's just more so for a visual lesson. Let's say 2 blocks, or 2 blocks is fine. And I said JK is congruent, JK is a segment, is congruent to MN, so you could see the notation for it. Then we could say that this measure is also 2 blocks. Now, it's optional to write this down. It's actually kind of useful though. The important thing that I do want you to write down is this. I'm going to erase this really quickly. To know that these are congruent to each other, we actually mark them on the actual segments. And the way we do that is we use what we call tick markers. We're just going to put this little line that's kind of close to the middle, or if not exactly in the middle, which is really hard to do. And we call these tick markers to show that they are in fact congruent. Tick marks. You can do this for angles as well. I will show you that in a different lesson, but it indicates that they are in fact congruent. So actually, let's put this in, not pink, let's put this in red, because that would be important to know. The tick markers, they indicate congruent parts, or congruency. Okay? All right. So a little subnote for this is if you have, for instance, different sets of congruencies, use a different number of tick markers. What I mean by that is, just really quickly in pink, let's pretend we have a segment here. Let's call this AB again. We have another segment here. That's CD. Third segment, EF. And then another one here, FG. I'm sorry, I already used F. GH. Oops, I already used G. H. Let's pretend these 2 segments are congruent. They were like 2 miles and 2 miles. But then EF is, let's say, 3 miles and 3 miles. We don't want to use 1 tick marker here for EF, because that would assume that these 2 segments are in fact congruent. We don't want that. So what we would do here is we'd actually put 2 tick markers for EF, 2 tick markers for HG or GH, to show that, hey, these pair of segments are congruent, as well as the AB and CD pair. Okay, so use different tick markers as needed. Just keep that in mind. The more you practice it, the more you'll understand that. Okay. The last thing I do want to talk about is the betweenness of points. Actually, there's kind of 2, and there's like a little subcategory to this. Betweenness of points. And it's exactly what it sounds like. If you have points and you are between them, you know that it is a sum of them. A sum of the 2 segments will make the whole segment. So that's a kind of wordy. Let's say this. Point A is between points C and T. And I should put a period there. A, C, and T are collinear, meaning they're all in the same line. Then we could assume this. So I'm going to draw this out just so we can see it. We have, for instance, C and T are 2 points. A is between them, so it has to be in the middle at somewhere. It doesn't have to be exactly in the middle. If, for instance, if we have A, C, and T all in the same line, which we do, then we could then assume if CA plus AT will be equal to all of CT. And you can see what I mean by this is because if we actually put some numbers in here, so let's actually put CA as a segment plus AT is going to be equal to CT. And I'm going to put this in pink. You don't have to copy this down. Let's say this is a length of 2 miles plus 5 miles has to be equal to the total of 7 miles because you from point C to point A, from point A to point T, they add up. Okay. And then the last thing I want to talk about is a kind of a subcategory of this, and it's called the midpoint. oops, let's actually write it out, not short it. Midpoint is a point on a segment, a point that divides a segment. Let's not shorthand this again. A point that divides a segment into two congruent segments. What I mean by that is this. Example, if O is the midpoint of DG, segment DG, then DO is congruent to DG. Those two segments are congruent. And let's see this visually. Point here, middle point. DG, O is the midpoint, so it has to be in the middle. And if this is truly the midpoint, then it breaks this up into two equal parts. If I said that this was, for instance, 10 miles, then this should be broken up to 5 miles and 5 miles. Okay? You could even put tick markers here to show that this is a midpoint. And that's your definition of a midpoint. Okay? I'm actually going to shift this up just a little bit just so it all stays on one page. And here we have it. Your midpoint is now shown. This is 10 miles. All right, so that's our lesson for the day. If you do have any questions, please let me know, and I'll see you in the next one. Bye.